regression, again, we saw this back in Unit 6 at the beginning of this semester. All right. And what regression is, just a reminder, it's basically we're using a calculator to set a function, regardless of its type, to a set of data or a table. All right. Now remember, regression does not mean that it is the exact equation for this set of data. It's just what we call the line of best fit. All right. So let's look at your journal. All right. So first off, we got your I can statement, which is, I can fit a quadratic regression model to a set of data using technology. So the great thing about regressions is that there's no actual formulas or calculations. It's all in your calculator. So if you know the calculator steps, it's really, really easy. All right. All you have to do is basically find the line of best fit or equation of best fit, and then you can answer some questions about it. But again, it's fairly straightforward. So again, we saw this back in Unit 6 with linear and exponential functions. But now to review, regression is when you fit a set of data to a function using technology. It can be any type of function. There's linear regression, exponential regression, quadratic regression. There's even some functions that you've never heard of, cubic, logarithmic, but we don't use those in this class. Now, not only are we going to see this now in this unit, we'll see it again in your last unit for this class, which is the stats unit, and we'll go more in depth with how you can use regression. But for this, I just want to make sure that you can actually put it in the calculator, find the equation. That's the main thing that I want with this. So we learned how to find linear and exponential regressions, and now we're going to find the quadratic regressions in both your Desmos and the TI-84. So I don't really have a preference with how you find the regression. If you like the TI-84 method, use that. If you like the Desmos method, use that. I don't think one is easier over the other. They both have their difficulties in terms of steps. But I mean, I grew up when I was learning all this stuff using TI, so that's probably the one I'm the most comfortable with. But you can also use Desmos as well. Desmos may be a bit more user friendly to you depending on what you prefer. All right, but I'm going to teach you both. So the first couple of steps, the whole front page is basically the TI-84 steps. So all of this on the front page is just TI-84 steps. So your first step would be right here, and that is to press Stat, Edit, then Enter, and enter your data into L1 and L2. That represents your X and Y values. All right. So we'll do a sample. Let's do this sample together. All right. So this is the table that we're putting in. L1 would be your X value. L2 would be your Y value. So in your calculator, first things first, I want you to hit mode before we do anything. So hit mode, and this screen should pop up. So mode is to the right of the second key. So that blue second key is to the right of it. I want you to scroll down. And I want you where it says Stat Diagnostics. So right here. make sure that it's highlighted on. If it's not, scroll down to it and hover it over the on and click enter. Make sure it's on. All right. When you reset your calculator a lot, it will turn off. So that's where you should always start. Make sure stat diagnostics is on. Once you do that, you can hit second quit and it'll go back to your screen. All right. Now, you're then going to hit stat. So the stat key is right next to your left arrow key. You're going to hit stat and this screen should pop up. Which one? So just hit stat and get to that screen. So just hit the stat button. That's all you need to do. All right, now hit enter. You should see something like this. Now, if your table is not cleared, you need to do it like this. So watch me. So if your table is not cleared, this is how you clear it. You scroll up, so that's hovering over L2. You hit clear. And then it will delete as soon as you move it. All right, you can do the same thing with L1. Just hover over, make sure the L1 itself is highlighted, hit clear, and then when you exit out of it, it goes away. Do not hit delete. It will completely remove a column. Just hover over, hit clear, it'll go away. All right. So take a minute, enter in that table that it gives you in L1 and L2. So enter in the table that gives you the L1, L2. So basically you type in a number, hit enter, type in the next number, hit enter, and so on and so forth. Oh boy. Dang it. So once you get all the numbers entered in, look up at me. So it should look like this when you're done. So everyone should be trying this in the calculator. It's not an option. Yeah, grab a calculator. All right, is everyone here? All right, so after we enter, this is how we get quadratic regression, this set of steps right here. So it's listed right underneath the screens that look like this. So look on the board, on your notes, it's these screens right here. You want stat. So this is a sequence of keys you're going to hit. Stat, the right arrow, so that hovers over calc, and then you're going to select 5 for quadratic regression. All right, so this set of keys. So what it will look like is that you will hit the stat key again. You're going to hit the right arrow key so that it's highlighted over calc instead of edit. And then you're looking for quadratic regression. So linear regression is 4. We've done that before. Quadratic regression is right below it, which is at 5. So you just click the number 5 and this screen will pop up. All right, everyone get to that screen. Take a minute, get to that screen. Again, the steps is stat, right arrow, 5. And again, the steps are right here in your journal as well. So stat, right arrow, 5. All right, so everyone at the screen. Now, all right, the next thing that we're going to do is we're going to now do the actual calculation. So all you got to do is just hit enter. Just keep hitting enter until you see this screen here. So keep hitting enter until you see this screen here. That's your end result. So this is your last result. So in your calculator, we're just going to keep hitting enter. And that screen pops up. Oh, don't worry about that. Just keep hitting enter. We'll talk about that in the next unit. I don't really care about that right now. So stat over 5, you're at this screen. Then you just keep hitting enter. I think you'll hit it like 3 or 4 times until you get to this screen. And what it does is that it gives you the standard form of a quadratic, so ax squared plus bx plus c. And it tells you that a is equal to 2.125, b is equal to about negative 4.43, and c is equal to negative 0.7642. The r squared we'll talk about later. We've talked about it before, but that's essentially the coefficient of determination. It's just saying that this fit is about 99% a good fit. So in other words, if I was to write out this function, it would be y is equal to 2.125 x squared minus 4.532x minus 0.764. That would be your equation of best fit for that set of data. So that's how you read it. They give you how you put it back into the equation, and then they give you the actual variables, so A, B, and C, and you plug it in for A, B, and C. So that's using the calculator. Now, for a lot of you, Desmos might be the easier one. So let's do that same table, but in Desmos. So pull up Desmos. So if I have Desmos pulled up, does everyone have Desmos pulled up? All right. So the very first step that you're going to do is you're going to click in the top leftmost corner that plus button. When you click that plus button, you'll see this drop down. the third from the top says table. You're going to click that to insert a table into Desmos. Then, just like you did with the calculator, you're going to take a minute, input the numbers in for X and Y from the same table that we just did. So take a minute, input for X and Y. So once you finish, your table should look like this. And another cool thing about Desmos is that when you do a table, your calculator automatically plots what the graph looks like or what the points are. So if you look at the points, it does look like it has a quadratic shape. All right. Now, to get the actual regression, you're going to click into the next available cell. All right. So the table's in one cell, the next cell's in another. So what you're going to do is you're going to type in the type of regression that you want. So on your journal, there's a couple that we use that we've already talked about. So linear, quadratic, exponential. I gave you all three of them just so you have them for reference. We're going to type in this into that cell. So Y1, the little squiggle key, AX12 plus BX1 plus C. Now, to do the Y1, all you do is do Y and then type a 1 after it. It should automatically do the subscript. So we're just going to type in Y1. Make sure you got the wee squiggle. So it's that squiggle key that's right next to the 1 key on your keyboard. Then AX1 all squared plus BX1 plus C. The reason that we're putting in the X1s and the Y1s is that we're telling your calculator to use this table, right? Because it has X1, Y1, yes. What? It's the key that's to the left of the 1 on your keyboard. So it's like shift and then hit that key. Now, it's a little hard to see on my screen, so I'll zoom in a little bit. So it automatically graphs the equation for you, and it gives you the parameters as well. So just like with the TI-84, it gives you A, B, and C when you have AX squared plus BX plus C. And it also goes ahead and plots the graph for you. All right. So again, it's not going to be a perfect, it's not going to go through every point exactly. That's not what a regression does. You just want it to be the best equation to fit what you're doing. All right. So it's up to you what you prefer. I don't care. I think in some ways Desmos is a little bit easier if you just want to automatically graph it. But if you like the TI version, like just for to get the equation, that's up to you. All right. So it just depends on what you prefer. You can do either way. All right. So let's actually look at some examples doing regression. All right. So I will let you guys pick whichever version you want to do it, whether you want to do it in the TI or Desmos, it's up to you. I want you guys to go ahead for number 1 and put in this table into either Desmos or your graphing calculator, where the angle is your X value, the distance is your Y value. All right, so take a minute. You can put it in Desmos, you can put it in your TI. It's whatever you want to do. But everyone should be putting that into their calculator. And go ahead and find the quadratic regression once you do that. Also, guys, if you're doing it in Desmos and you delete your table and make another one, just make sure that it still says Y1, Y2, or X1, Y1. If it says X2, Y2, just change it. You can go up and click it and change it. So I should see everyone typing this in either in Desmos or in your graphing calculator. Yes. Okay. All right, guys, heads up. So I typed mine into Desmos. Now, before I even show you what the regression equation looks like, this is the scatter plot, or in other words, the plot of the points that we just made from this table. What type of function does it look like, just right off the bat? So if we connected these dots, what function would it sort of look like? It would look like a quadratic. That's why we would use a quadratic regression. So if it doesn't tell you exactly which type of regression to use, look at the scatter plot and be like, okay, this could most likely fit a quadratic. All right. And see which one fits the best. So this definitely looks like a quadratic regression. Now, if I round to the nearest tenth, so 1 decimal place, what would be the equation for the data? Y equals what? So what's the numbers that it gave you? So in other words, if you're looking at these parameters right here, if you round to the nearest tenth or 2 decimal places, what's your equation for the line of best fit? Come on, guys, someone just read me the numbers. Negative 0.26 x squared plus what's your b value? 22.25 or okay, so 22.6x. What's the last number or your c value? 23.02. So plus 23.02. Yep. So that's all you got to do when you write that equation. You just take the values for y equals ax squared plus bx plus c, and you take whatever they give you for a plug it in, take whatever they give you for B, plug it in, take whatever they give you for C, and plug it in. All right. And if we look at the graph of the model, is that in fact a quadratic graph? Let's look at the graph now. Does that look like a quadratic graph? Guys, come on. Yes or no? Is this a quadratic graph? Yes. So it is, and it looks like it goes fairly well through the points of our function. So we're going to assume that it is a quadratic regression. All right. Now, try the next one. Yes. Yeah. Well, when Michael gets back. Or actually, we're about to take our break after we do this problem. All right. So take a minute, input this table, find the regression. So my little sleepy heads, put your heads up. Come on. What's up?
Date for the immunity test.
Wednesday.
Of this week?
Wednesday. No, you're good. All right. Did everyone get the function? All right. So, first off, we know it's going to be a quadratic regression. However, the last one was a pretty nice lineup. But what do you notice about where the actual points are? So I got my line of best fit, but I also got my points. If I remove the line of best fit, why do you think this is called a scatter plot instead of just strictly the points of a parabola? What does it look like to you? So why are these points not quite a parabola? So why would this be called a scatter plot instead of a parabola? They're more scattered. There's not really any rhyme or reason to them. It's just kind of data points. Even if we put the quadratic line over it, if you look, they don't quite line up, which that's okay. We're trying to find a line of best fit. So the reason that it's a scatter plot is because the points are discrete data with no pattern. It's data that someone collected and they weren't looking for a pattern. All right, it's just what happened. Yes. 18th. Mm-hmm. Now, what's the quadratic function? So y would equal what? And I want you guys to round to the nearest tenth, so 1 place. So if y is equal to ax squared plus bx plus c, what are my a, b, and c values? So what's my a value? What's it say? Negative 0.01. So negative 0.01 x squared. What's my b value? So guys, if you did it, you're just reading off your computer. What's my b value? 0. What? 0.75 plus 0.75x. And then what's my c value? Say that one more time. 13.47. So plus 13.47. So this represents my line of best fit. This best describes my data. Now, given what the problem's asking us, so a study compared the speed x in miles per hour and find the average fuel economy y of miles per gallon for the cars. What exactly does the quadratic function represent in terms of gas mileage and the speed? So in other words, what are we looking for? So in other words, if we're going this fast, how much gas are we using? All right, that's what it's looking for. So it's saying if we use X amount of gas, or if we go X miles per hour, because it's speed, then we use Y or no, not we use, we get Y miles per gallon mileage. So basically, a lot of you probably don't have your driver's license yet, but you have at least taken driver's ed. So basically, you guys know about the mileage of a car, right? Like the gas mileage. The better the mileage, the more gas that you, or the more money you save on gas, essentially. So you want a car that has decent mileage because it's basically saying if we're going this speed, this is how much gas we're using. So this is the mileage that we're getting per gallon. So like, for example, some cars go about 25 miles per gallon if you're going at a constant speed. Some cars can do about 30, some cars can do 15. All right. So that's telling you how many miles you can get out of 1 gallon of gas in your car. So find the speed that maximizes the fuel economy. So based off of the graph, all right. So if we're looking back at this graph, I just want to look at the line itself. So if it helps, you can cover up the plots by clicking off the blue part. So if we're looking at the graph, we're trying to find the speed that maximizes the fuel economy. Keyword maximizes. So what do you think I'm going to look for on the graph? The vertex or the max. And it already graphed it for us right here. Now, we're trying to find the speed. So which value do you think I'm going to use, the x or y? the x, because they said x represents speed. So the vertex is where it maximizes, because that's the max of our graph. And we would use the x coordinate, because that's what they said speed is related to. It represents speed. And that maximized speed would be about 45.5 miles per hour. So if you go about 45.5 miles per hour, you'll get the best out of your mileage. Now, make a prediction about how much fuel you would use if you were going 42 miles per hour. So, how do you think I'd find that? Say it again. You could replace x. So we could take our original function up here and replace x. So we would have y equals negative 0.01 times 42 squared plus 0.05 times 42 plus 13.47. So all I did was they gave us the speed, which again, that's our x value, and we just plug it into our line of best fit. And for that, guys, you can just put that straight into your calculator. So I got negative 0.01 times 42 squared plus 0.75 times 42 plus, what was it, 13.47? Hit enter. We can say that our mileage will be approximately 27.33 miles per gallon. So we have to say it's approximate because it's not the exact. So it's approximately 27.33 miles per gallon. Now, another way that you could do this besides putting it in, so another way you could do this besides plugging it into your function and then putting it in your calculator is you could also just find it graphically. So if they give you your x value for 19, you could always do x equals 19, put that into Desmos, and find the point of intersection with your line of best fit. So in other words, in Desmos, I can plot in x equals 19. I get this black line right here. All right, here's my point of intersection. Which part of the point am I using for my answer? So in other words, I already have x, so that means I need what? The y. So my answer would be approximately 24.685 miles per gallon. So y is approximately 24.685 miles per gallon. So like I said, guys, these are not hard. It's all, can you put it in a calculator, find what you need. All right. And then a lot of it after that, any questions they ask you regarding regression, it just means plug a number back into your function, or you can make a line in Desmos, find the point of intersection. Any questions on this? All right, so we're going to go ahead and take our 5-minute break. When you guys come back, there is a delta math on this. All right, so go ahead and take your break.